Hello everyone, this video lesson is for combining like terms. It goes together with its partner video lesson about the distributive property, so I call this one lesson 3B. In this case, I don't have a batch of sample problems at the beginning for you to try out in order to tell yourself whether or not you need to watch the rest of the video. I would like everyone to watch this video because, well, I want to do a few things. I want to eliminate any misunderstandings anybody might have developed when they took Algebra 1. I want to make sure that everybody has the same vocabulary and we're all talking about the same things. And then lastly, I want to show you a typical word problem that makes use of the combining like terms skill to make sure everybody can solve that kind of problem. Let's get started. First of all, like terms, as it indicates here, are ones that have the same variable raised to the same power. So for example, 5x and negative x squared in this are not like terms. Yes, they both have the same x variable, but they're not raised to the same power, so those can't be combined. Also, just for vocabulary purposes, I'll refer frequently to constants and constant terms. Constants are numbers that don't have any variable associated with them. They're just the number itself. Constants are what you first learned back in elementary school. Coefficients are those numbers in front of variables. In this one it's obvious, it's positive 3. In this one it's a little less obvious, it's negative 1. But there is a coefficient on that x of negative 1. So go ahead, actually I'll do the first one, 19. I'll circle the like terms in the list number 19. There they are in blue. The other two, 8 and 4x squared, can't be combined with anything else in question 19. Now hit the pause button, do the same for 21 and 23, and when you come back I'll show you the answers. Okay, I'm going to assume that you did that. There they are for 21 as well as for 23. Notice there's nothing you can do with this b plus 5 term. You can't put it together with the others. You can't break the b out from the plus 5, just as you can't break the a out and put it together with the 3a in this one. Okay, and then second one. This one, go ahead, simplify this expression down as much as you can. Hit the pause button and simplify it as far as you can. Okay, I'm going to assume that you've not only identified the like terms, but you've combined them. If you haven't, hit the pause button again and go ahead and combine, because I want you to simplify this as far as you can. Okay, there are the combined like terms, and there's the answer. I don't particularly care what order you put these three terms in. We'll talk during the year about the idea that generally we put the term with the largest exponent first, so you might have put it as 6x squared minus y plus 1, but this order that's represented here in blue, red, and green is perfectly fine also. Okay, two other examples, obviously here based on the graphic design, taken straight from the textbook. The first one, I just want you to notice, they're talking about the fact that they've used the distributive property in simplifying this, but what they actually did is the reverse of what we're used to seeing. Usually when we see the distributive property, we would start with the thing on the right and distribute that 8 to the two pieces and get what we have here on the left. In this case, that's not what we want to do. We want to put things together. This is one way of seeing how you combine like terms. I see it a different way personally. I look at it this way. I say I have 8 of these things called x and another 3 of these things called x. If I put them together, I've got 11 of these things called x, and that's how I see it. But the way the textbook authors are representing this, and it's perfectly fine, they're saying you've got 8x and 3x, factor the x out. They're saying take the x, which is the common thing to both of these things, out and pull it outside parens. And what you're left with inside the parens are the 8 and the 3. And then they put the 8 and the 3 together and get 11. Two different ways of seeing the same thing, but I just want to make sure you're used to seeing this because you will see the textbook represent it this way, and other math teachers represent it this way fairly often. It's just the reverse direction in the distributive property. Now, question C here. This is a fairly typical combination of distributive property and combining like terms. Let's see if we can solve this one. The first thing we would have to do is distribute that -2. They've decided to call it plus negative 2. And then they distribute that negative 2, as I say. Negative 2 times 4, as well as negative 2 times x. Well, negative 2 times 4 is negative 8. Negative 2 times x is negative 2x. The reason they made it plus negative 2 is for you to realize that the negative has to stay together with that 2. So we've got 3 plus this multiplied plus this multiplied. Negative 2 times 4 is negative 8. Negative 2 times x is negative 2x. And now 3 plus negative 8, in other words 3 minus 8, minus 2x. Well, 3 minus 8 is negative 5. Minus 2x, negative 5 minus 2x. And that's your answer there. So make sure you understand that negative 5 minus 2x is completely simplified, and these earlier steps along the way are not finished answers. I'm going to assume that you've thought that through and are ready to move on to the next slide. Go ahead, hit the pause button, and do this one yourself. Okay, I'm going to assume that you've done that. I'm going to assume that you've distributed the 4x to both pieces inside the parens, and you've combined everything together, including the negative 2x. If you've done all of that, you should finish off with the answer 18x minus 4x squared. And if you don't see that, here are the steps to get there. Hit the pause button if you need to make sure you understand all of those steps and would be able to solve a problem like this the next time I give one to you. Okay, I'm going to assume that you've looked that through. Come to class if you have any questions about this, please. But we're going to move on. Last thing now, a typical word problem that makes use of combining like terms. Let me walk you through how to do this. Actually, first, why don't you hit the pause button and read the paragraph to yourself. Okay, I'm going to assume that you've had time to read it and now are ready to see how to solve it. I would start by drawing a picture. There's my picture. Luckily, I've got a little graphic design tool here, so it wasn't too hard to make a weight bar. Now assign numbers to the weights. The biggest one they say is x. The next one down is 5 pounds lighter, so it's x minus 5. The next one down is 5 pounds lighter than the middle one, so it's x minus 2 times 5. And the same holds true for the right side. I've got matching sets on the right and the left. So now, what I want you to do, and hit the pause button, is to write an expression that models the weights on the bar. Hit the pause button, and when you come back, I'm going to show you the answer. Okay, I'm going to assume that you've done that. I would put it together this way. The blue ones are the lightest, the red ones are the middle, and the green ones are the heaviest. Notice I've got 2 of these x's, that's why it says 2x, and 2 of these things called x minus 5, and so on down the line. Now multiply everything through and simplify. The blue ones become 2x minus 20, the red ones become 2x minus 10, the greens 2x. And simplified all the way down, you would get 6x minus 30. Here's a last challenge for you. Rewrite the expression and simplify it all the way down if each weight was 10 pounds lighter than the previous one. So in other words, this one's still x, but this one's now x minus 10, and you have to figure out what that one is. Hit the pause button. When you come back, I'm going to show you the expression as well as the answer. Okay, I'm going to assume that you've done that. The expression, all you really have to do is change the 5s to 10s, so it becomes 2x minus 40 plus 2x minus 20 plus 2x. Simplified all the way down, it becomes 6x minus 60. Alright, that's it for the video lesson. If you have questions about any of this, don't hesitate to bring them to class. I look forward to seeing you next time.